It was your user. He downloaded into you, manipulated you.
Like a puppet.
A puppet doesn't have a soul.
I can't have a soul anymore.
If one wave meets the bottom of another, they interfere and cancel each other out. This results in an interference pattern on the back wall. Where the waves reinforce each other, they are at the highest intensity, the bright lines. And where they cancel each other out, there is nothing. So, when we fire objects through two slits, we get two clump patterns, but with waves, we get an interference pattern. An electron can be seen as a very small bit of matter. And when a stream of electrons is fired through one slit, they behave like small objects, forming a single clump pattern. So if we fire these bits of matter through two slits, we should get two clump patterns. But we don't. We get an interference pattern. We fired particles through, but we get a pattern like they're waves, not like little objects. How can pieces of matter create an interference pattern like waves? It doesn't make sense. At first, physicists thought that the electrons were bouncing off each other to create this interference pattern. So, in 1961, Klaus Johnson at the University of Tübingen in Germany modified the experiment to fire the electrons through one at a time. This way, there is no possibility of them bumping into and interfering with each other. But again, the interference pattern was seen. Physicists were perplexed by this.
It somehow seems to have been aware of there being two slits, not one, because it's given rise to this interference pattern. How does one atom do that? Does it split in half? Does it become like a cloud that goes through both?
The path taken by the photon is not an element of reality. We are not allowed to talk about the photon passing through this or this slit. Neither are we allowed to say that the photons pass through both slits. All this kind of language is not applicable.
So they further modified the experiment to get to the bottom of the mystery. They put a measuring device at one slit to see which one the particle actually went through. But when the electrons were being this closely observed, they went back to behaving like little objects and produced a clump pattern, not an interference pattern. Somehow, the act of observation meant that they only went through one slit, not both. The electrons seemed to decide how to behave as if they were aware of being watched. How could this possibly be the case? Could the presence of a conscious observer be influencing the experiment?
Consciousness is information. It's an information field. Okay? It's data.
In 1978, physicist John Wheeler proposed a new way of doing the double-slit experiment that might finally reveal what's really happening. He proposed what is called the delayed choice experiment, in which the decision of whether or not to observe the particles isn't made until after they have gone through the slits, but before they've impacted the detector. This animation is highly simplified, but you get the idea. Here comes the light. It travels through the double-slit barrier as waves. The waves are past the slits but haven't yet hit the detector. And here comes the scientist. His eyes are closed. He's delaying his choice to make this an observed experiment. And then... The results of the experiment didn't solve the mystery. Instead, it got even stranger. Because what was found was that at the moment of decision to observe, the waves became particles. And not only that, but they actually made a record of themselves as having traveled through the slits as particles. Yes, you heard me. Deciding to run the observed experiment causes the waves to become particles, and this causal force extends backwards in time.
Our choice of what experiment to do determines the prior state of the electron.
Running the experiment unobserved does not cause this effect. When John Wheeler first proposed adding the delayed choice protocol to the double slit experiment, he asked us to imagine a distant star that emits a photon billions of years ago and sends it towards the Earth. However, on the way, it must pass a dense galaxy. Gravitational lensing will make the light bend around the galaxy. Billions of years later, upon reaching the Earth, an astronomer chooses to use a binocular-type detector and focuses half of it on the left side of the galaxy and half of it on the right side. How the astronomer chooses to measure means the photon could only have taken one path and would display a clump pattern. So how we choose to observe in the present determines how the photon behaved billions of years ago. What John Wheeler had predicted was confirmed by the experiment. This doesn't make sense in the materialist worldview. It only makes sense if the universe is a simulation and all parts are equidistant in space-time with respect to the source of the simulation, like in a video game or a dream.
The Force? The Force is what gives the Jedi his power. It's an energy field created by all living things. It surrounds us and penetrates us. It binds the galaxy together.
Max Planck famously said, "There is no matter as such. All matter originates and exists only by virtue of a force. We must assume behind this force the existence of a conscious and intelligent mind. This mind is the matrix of all matter." One of the hottest ideas in cosmology is known as the holographic principle. It's the idea that our three-dimensional universe is emerging from 2D information. That is, three-dimensional objects are composed of information spread out on a two-dimensional surface, in the same way that a hologram produces a three-dimensional image from two-dimensional information. The holographic principle tells us something very surprising. It says that our ideas of volume, and in a sense, the world, might be a kind of illusion.
First of all, I would say it should be clear that this whole holographic story is the most radical thing that has happened to our understanding of space, time, matter, since the invention of quantum mechanics and relativity.
Quantum theory in general, and the results of the experiments that have been run in this area, reinforce the holographic principle. Is there any test that we could do to scientifically prove that the universe is a virtual construct and not materialist in nature? Well, you may think that scientists would have run out of ways to do the double slit experiment. But you'd be wrong. The delayed choice quantum eraser experiment was first performed in 1999 by Marlon Scully, Yoon-Ho Kim, and collaborators. Dr. Kim was consulted to ensure the accuracy of this presentation. The experiment begins in the top left corner with a photon source behind the barrier with two slits. A crystal is placed in front of the barrier which splits the photons into entangled pairs. This lens has the task of directing one of each pair, which have traveled through either slit, so that they will impact at detector 0. When a photon comes through the first slit and is split into an entangled pair, one of them flies through the lens and into detector 0. The second flies downward and is redirected by the prism into the green half-silvered mirror. Half-silvered means that they allow light to pass through 50% of the time. The other 50% are reflected. So, on average, half of the photons are reflected up and impact detector 4. The other half simply travel through, reflect off a full mirror, and reach another half mirror. They can either travel through it and hit detector 1, or be reflected into detector 2. Photons traveling through the second slit are also split up into pairs, with one traveling down and redirected by the prism. At the first half mirror, 50% are reflected and impact detector 3. The others travel straight through and are reflected into the second half mirror. 50% of these travel through and impact detector 2. The other 50% are reflected and hit detector 1. So, all the photons that came from the first slit on the red path could only impact detectors 1, 2, and 4. They can never reach detector 3. All photons coming from the second slit, the blue path, can only impact detectors 1, 2, and 3, but never detector 4. So any photons hitting detector 4 must have traveled through the first slit, and any photons hitting detector 3 must have traveled through the second slit. For photons that impact detectors 1 and 2, it is impossible to determine which slit they came from, because these two detectors can be reached from either red or blue path. The path of their actual origin has been erased by the experimental setup. So what is the function of detector 0? The results of the experiment are related to the time it takes the photons to travel through the apparatus. The shorter the path, the faster the photon reaches the detector, and the shortest path is always to detector 0. So when the photons are split up into pairs, one of them is always recorded at detector 0 first, and then, with a delay, the partner photon hits one of the other detectors. The coincidence counter records the results of all 5 sensors. It establishes a connection between the measurements at detector 0 with the partner photons that reach detectors 1 through 4. This way, each single photon registered at detector 0 can be precisely assigned to a partner at the other detectors.
Let's get ready to rumble!
This showdown was 2,500 years in the making, and it's for all the marbles, folks. They're playing for the entire universe. It's Plato versus Democritus, idealism versus materialism. Head to head, winner takes all.
Now, this apparatus can get moving along at a pretty good clip. So they fire a whole slew of photons through here, let the experiment run, gather plenty of data, and then run the analysis. And what are the results? Detectors 1 and 2 always show interference patterns because it's impossible to determine which of the two slits the photons came from. But detectors 3 and 4 always show clump patterns because we can know which slit these photons came from. That is the only difference. How the light chooses to display itself as particles or waves is dependent on how much we know about it. If it had to come from just one slit, clump pattern. If it might have come from either slit, interference pattern. There is no materialist explanation for this. But even more mind-boggling is that the photons know beforehand which detector they will hit. How do we know this? Because of how the twin behaves at detector 0. Because the path to detector 0 is shortest, one of the split pair registers here first, before its twin ends up at any other detector. And whatever registers at detector 0 always correlates with where its twin ends up. So if one of the pair hits detector 3 or 4, detector 0 always displays a clump pattern. But if its twin lands at detectors 1 or 2, detector 0 always displays an interference pattern. Can the particle predict the future? Or is space-time a virtual construct with all time frames available simultaneously at the source of the simulation? Modern physics has definitely decided for Plato. The smallest units of matter are, in fact, not physical objects in the ordinary sense of the word. They are potential forms. In Plato's sense, abstract ideas.